An acid's strength is defined by where it lies in the equilibrium of the reaction. Strong acids lie far to the right of the equilibrium reaction, while weak ones lie far to the left. What does this mean? Basically, if we have HCl plus water, it will dissolve into H3O plus and Cl minus. Since HCl is considered a strong acid, there will be more of these components than these components in the solution. After the dissociation reaction, strong acids will always yield weak conjugate bases, and strong bases will yield weak conjugate acids, and vice versa. Strong acids, which are listed here, will always completely dissolve and will yield the weakest conjugate base that is even weaker than water. In this question, it asks us to identify the weak and strong acid in the following reactions. So just by simply looking at it, we can tell that HA dissolves completely into H plus and A minus, while HB, only a small portion of it dissolves into H plus and B minus. So we can instantly tell that HA is a strong acid, while HB is a weak acid. However, we can also infer from this figure that A minus is a weak base, while B minus is a strong base. That is because stronger acids will always yield weaker bases. Listed below are the ways to describe acid strength. Firstly, we have the Ka value, which, as mentioned earlier, is the products over the reactants. Then we have position on the dissociation equilibrium, whether it is far to the right being strong or far to the left being weak. Comparing the concentration of H plus ions in the solution to the amount of HA acid in the solution, and comparing the strength of the conjugate base, where a weaker conjugate base will yield a stronger acid. In this chapter, we will be taking three types of acid: hydrohalic acid, where an H plus ion will bond to a halogen atom, which is that of column 17. Oxyacids, where H plus will bond with an oxygen atom. And organic acid, which are acids that contain carbon backbones, such as methanoic acid, ethanoic acid, and propanoic acid. Note that in these, they will usually be followed by a hydrogen, so it would be like CHOOH. We would never take this H. We would only take the ones that are farthest on the edge. In this question, they ask us to arrange the following acids according to the strength of their conjugate bases. So what we would do here first is identify the weakest acid, which happens according to the table to be HCN. So Cn minus would be the strongest. The second strongest according to the table is HNO. So it would be NO2 minus. Then we have HF. So it would be F minus. Now here we see HCl is not mentioned anywhere in the table. That is because it is a strong acid and the K value of strong acids is usually too high to be listed. And we know that strong acids yield the weakest conjugate bases. So in this case, water, or H2O, is a stronger base than Cl minus. So you may have noticed something by now. Water can be both an acid and a base. This makes water amphoteric, which meaning it can behave as both an acid or a base depending on the circumstances. The Ka value of water, also known as Kw, at 25 degrees Celsius will always be 10 to the power of negative 14. No matter what solution you have, you can always depend on this being 10 to the power of negative 14 at 25 degrees Celsius. In an aqueous solution, we can get the Kw value by multiplying the H plus concentration by the OH minus concentration. Using what we just now learned, we can create the formula 10 to the power of negative 14 is equal to the concentration of H plus multiplied by the concentration of OH minus. And since Kw is always constant at this number, if we have one value, we can always find the other. Some some things to keep in mind. If the H plus and OH values are equal, then the solution will be neutral. If the H plus has a higher concentration than the OH minus, then the solution will be acidic. If OH minus has a higher concentration, then the solution will be basic. In this question, we are asked to calculate the H plus or OH minus value, depending on the given, and determine whether it is neutral, acidic, or basic. So in the first one, we are given the concentration of OH. So we just use the formula 10 to the power of negative 14 is equal to the concentration of H plus multiplied by the concentration of H minus, which in this case is 10 to the power of negative 5. If we put this in our calculator, we will get the concentration of H plus is equal to 10 to the power of negative 9. Here we are also given the OH minus value, so we just use the same formula. Just substitute the value, and you will get that the H plus concentration is equal to 10 to the power of negative 7. Here we are given the H plus value, so we just use the same formula, but instead we substitute H plus for 10 and multiply it by OH value as the variable, and we will get the OH minus value is equal to 10 to the power of negative 15. Okay, so now we move on to the second part, which is determining whether it is neutral, acidic, or basic. In A, the OH value is, or the OH concentration is 10 to the power of negative 5, while the H concentration is 10 to the power of negative 9, meaning we have more OH than H plus, meaning this solution is basic. In B, we have the same amount of OH minus as we have OH plus, or H plus, meaning this solution is neutral. And in C, we have way more H plus than OH minus, so we can immediately tell that this is acidic. These are just some questions to revise your understanding of the lesson. So in the first one, they ask, if water is a better base than A minus, do products or reactants dominate at equilibrium? Since water is a better base than A minus, you can immediately tell that HA is a strong acid, which means that the products will dominate the reaction. In the second part of the question, they ask us if HA is a strong or weak acid, and as mentioned here, HA is a strong acid. So is the Ka value greater than or less than 1? For acids that are for strong acids, we can immediately tell that it is far greater than 1.
That'll be it for lesson 14.2, acid strength. If you have any questions, want to ask anything at all, you can ask it down below in the comment section or in the server. If you want more tutorials like these, you can find them on the channel, and yeah, enjoy them.